So, hello everyone. Hello. So, in this video, I'm gonna show you guys how to convert a decimal, CIMAL, to binary. So, some number in base 10, some n in base 10 to some number in base 2. So, pretty much, this process requires a lot of division and a lot of remainders that you have to keep track of. So, I'm gonna use a few examples. I'm gonna use the number, let's say 4. Let's convert 4 into binary. 4 in base 10 to some number in binary. So we basically set up 4 and divided by 2. So 4 divided by 2 is 2 remainder of 0. So as we know, we put the number 0 as our first number. I'll probably erase that. Something like this. As our first number to the right hand side, and then we take this 2 over here. We divide it by 2 again. 2 is, 1 remainder of 0. And then we put this down here again, and then we take our 1, divided by 2. Obviously we can't do that, and so we just end up with a remainder of 1. And so our number 4 as a base 4 decimal in base 2 is 100, and you can test this by knowing that the weight, obviously, so this is 2 to the power 0, 2 to the power 1, 2 to the power 2, right? And 2 to the power 2 is obviously 4, plus 0 times 2 to the power 1, plus 0 times 2 to the power 2, so 4, so that checks out. So, and then that's for that, and then we're going to move on to, oh god, nope, okay, no, okay, hi, stop, okay. Is there, I wish there was a way I can access my stuff. Please? Hello? Okay. I just have to do that. Yep. Okay. Thank you. Alright, so let's try bigger number. Let's say 135. So, 135. Okay, that's probably pretty poor. So 135, and we're going to divide it by 2. Oh, man, I have to fix up my handwriting. Okay, 135. So 2 goes into 13 about 6 times, so that's 12. Minus 1, 5. 2 times 7 is 14. So that leaves you a remainder of 1. So we'll put that down. So 1. And then 67 divided by 2. 67 divided by 2. 3, 0. And then you get 7. So times 3 is 6. Remainder of 1. So we'll note that it's 1 and 1, right? And so 33 divided by 2, so 2 goes into 3 one time, remainder of 1, so just 2, so that gives you 13, 6, gives you 12, so it still leaves you a remainder of 1, so there's another 1 added over here. You add the remainders from right to left. So 16 divided by 2 goes in about 8 times, remainder of 0, and then you're gonna, so we have 3 1s and then 0, and then 8 divided by 2 is 4, remainder of 0. So once again, remainder of 0, put that remainder over there. I know it's a little bit messy, but this is pretty impromptu. Then we get 4 divided by 2, and then 2 goes into 4 2 times, so a remainder of 0 again. So we have 3 1s and 3 0s, and then 2 goes into 2 one time, remainder of 0, and then we have another remainder, so 0, and then we get 1 divided by 2, oh, okay, wrong color. Yeah, 1 divided by 2, 0, remainder of 1. Alright, fantastic. And whenever you get that, you're kind of done. Because if you get 0, you divide it by 2, You get 0 again, and then you get a bunch of zeros, right? And so you can add as many zeros in front of this as you want. So pretty much to sum it up, 135 base 10 to translates to 1, 1, 2. Oh, translate to pretty much this number down here in base 2, right? And we can test that out as well. So we can go, let's do some funny maths. So we know that this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So 2 to the power 7, I believe. I'm going to use a calculator for this because I don't really remember. Okay, so it is 128. So 128 plus 4 plus 2 plus 1, right? So 128 plus 4 plus 2 plus 1 gives you 135. So 135. So that checks out. So yeah, that pretty much sums it up on how you can convert decimal to binary. So pretty much the process is you divide a whole lot and you get a remainder. You keep the remainder to a point where you get 0 as your quotient, and whenever you can just get a bunch of zeros, you know you can end there. Usually terminates around here, and it's kind of straightforward. So yep, that's pretty much it.